Hello, Year 5. So we're on to lesson 2 now. Today's date, 23.2.21 or 2021. Obviously, we've got our Roman numerals date here as well. So we've got X, X, and then I. So 20, each of the X's is worth 10, isn't it? And then we've got 111, so that's 23. 2, and then 2000. M is worth 1,000, isn't it? So that's 2021. Okay, here is our percentages lesson. We're digging deeper now, thinking about percentages. So let's have a look at our in focus. We have got Ruby, Lulu, and Elliot, and each of them have scored some baskets. We've got Ruby, who says, out of 10 throws, I scored 7. Lulu, out of 25 throws, I scored 15. And Elliot, who says, out of 20 throws, I scored 13. And it says, whose score is the best? Just drawing your attention to how this is spelled, because this is a mistake lots of you make, where you write WHO''S, which is who is, rather than using the relative pronoun whose, okay, because it's referring to whose score. So, whose score is the best, and how would we go about working that out? Now, yesterday, we had a think about the show it, draw it, explain it, and prove it model. And we're going to have a go at doing that today. But before we do, I want you to have a little look at this. So Hannah says that Ruby scored 7, Lulu scored 15, and Elliot scored 13. And she says that Lulu's is the best score. But what is wrong with Hannah's method? And when does Hannah's method work? So maybe spend a bit of time just having a think about that before we do anything else. And can you jot down in your books, what do you think? Why is Hannah wrong? What's she done wrong? And when could she do that? And under what circumstances would she be able to actually just say, Ruby scored 7, Lulu scored 15, and Elliot scored 13, and therefore Lulu is the winner? So pause and have a go at that in your books, please. I'd love to see that in your squared paper books. Okay, right, guys. So don't worry about this being really small. Obviously, I'm going to talk it through, but you've got a copy of this attached to the tapestry post for today. So you can, if you want to, you can print it off, but you don't need to, all right? You can literally just write the title, show it, draw it, explain it, and prove it in your books. So please don't print off anything that you don't need to. And this is simply the in focus question. So that's nothing different to what you've already got. So you don't need to print it off. It's just us showing you what we are using and the little sheet that we might start using when you come back to school, okay? So we're going to start off with our show it section like we did yesterday. So, show it, show this. I just keep spelling this, keep writing this wrong. I don't know why. So this is our show it. Okay, so you're going to have a go now at thinking about how you might show this. Now, think about what I did yesterday. Could you use something similar today? Is there any way that you might be able to show each of their scores, imagining that you had equipment? What equipment might you use? Maybe you could draw that equipment that we might be able to use to show what each of their scores was. So in your your squared paper book, have a go at that now, pause the video, and then come back when you've had a go. Right, let's see. So this is what I chose to do to show it. And hopefully you may have done something similar, you might have done something different. It doesn't matter. Remember what we said? No right or wrong answer with this one, which is really nice. So I decided to show each of them with a fraction, but using Deans. So I've got Ruby, who scored out of 10 throws, I scored 7. Now, they've deliberately given you it in a bit of a roundabout way to make you think a bit more. So it isn't 10 out of 7, it's 7 out of 10, isn't it? Because out of 10 throws, that's the number of throws in total. And so we know that's the denominator, and she scored 7, so that would be our numerator. So I've shown it here by taking the ones Deans to show 7, and then 1 tens Dean to show out of 10, so 7 out of 10. I've done similar then with Lulu. Lulu scored 10 and then another 5, so 15 out of 25. And then Elliot scored 13 out of 20. So I've shown it like that, and there's different ways you could show it. But that's how I've chosen it. Like I say, no right or wrong answer. So let's have a look then at draw it. Right, now yesterday, if you think about, I actually did some writing. I drew some, I chose to do decimals, I chose to do some with words, and I chose to have a go at showing some fractions. So how might I show this? Now we need to start to think about how we're going to answer the question. So we're not necessarily just going to take what we've just shown and write it as fractions. You need to take it a step further now and think really carefully about how are we going to show this or draw this so we can start to have a go at answering the question. So I'm going to give you some time now, pause the video and have a little think about that. Okay, right, hopefully you're back with me having had a think about it. So I'm going to just show you that to start with. Let me just think really carefully about what I might have done. Right, okay, so let's have a look at it. So I have realised that in order to be able to compare the scores, what Hannah did wrong is that she actually just took the numerator, and what she didn't realise was that the denominator is actually different for each of them. Now, if the denominator were the same, she could just look at the numerator, but it isn't, is it? We know that actually they all threw a different number of balls for their goals, so, or for their baskets rather. So Ruby had 10 shots at the basket and only got 7. Lulu did 25 shots and only got 15. And Elliot did 20 shots and only got 13. So they each had a different number of tries, which means that we can't just compare them by saying, oh, well, let's say Lulu did the best because she got 15. That's not a fair way of doing it, is it? So we've got to look at what percentage of those throws they got right, or they scored. Now, before we can actually figure out percentages, I think what we need to do is have a look and see, well, what would those be as fractions out of 100? Because we know that percent is out of 100. We need to convert each of our fractions so that they're out of 100. So I'm not going to say any more. I'm going to leave you, if you haven't already done this, to look at this on the screen and see if you can find a way that you would be able to convert each of their scores into a fraction that is out of 100. Come back to me when you're ready. Okay, let's have a look then and see what that looks like. So this is what I have done, and this is what you should have done to be able to convert. To convert from, to find the equivalent of 7/10, when we've got a denominator out of 100, we need to think, what do I multiply that by to get 100? So 10 multiplied by 10 is 100. And we know that we do the same to our numerator as we've done to our denominator. So we've done the same up here. We've multiplied by 10. 7 multiplied by 10 is 70. And that's what we have done here. But if you have a look, our number is different. If I just did the same thing, 25 times 10, I'm actually going to get out of 250, and that's no good. So don't just go, oh, yes, every time I need to multiply by 10. What I have done here is I've gone, oh, what's my new multiplier? What do I need to multiply 25 by to get 100? So this time, well, I know that there are 4 lots of 25 and 100, so I have to multiply 25 by 4 to get 100. So I do the same to my numerator, which gives me an answer of 60 out of 100. And then here, 20, I know that there are 5 lots of 20 and 100, so my number that I multiply by is 5, multiplied by 5. So I do the same to my numerator. So that then gives me a much clearer way of comparing them. I now know that Ruby got 70 out of 100, Lulu got 60 out of 100, and Elliot got 65 out of 100. Now, can I take those numbers and now convert them into a percentage? I can, can't I? Because this actually means out of 100. So percent means out of 100. So let's have a little look at how I've explained it. Okay, so I've written Ruby scored the highest percentage of throws. Because if you look, Ruby got 70, Lulu got 60, and Elliot got 65. So I've explained it here. Ruby scored the highest percentage of throws. She scored 7 out of 10. This is equivalent to, equals 70 over 100, which is 70%. Elliot scored the next highest because he scored 13 out of 20, which is equivalent to 65 out of 100, which is 65%. And Lulu scored the lowest because she scored 15 out of 25, which is equivalent to 60 out of 100. And this is only 60%. So quite a lot of explanation there, because I've got to link it back to that original fraction. I can't just say she scored 70%, because how would somebody know that? If I hadn't really clearly gone through that process, I need to demonstrate what process I went through to make sure that I figured out what my percentages or what their percentages were. Okay, let's have a look at our final step then, prove it. Right, now, again, like I said to you, there are so many different ways that you can prove these things. This is just the way that I have chosen to do it. So I've shown it in the same box, look, the same size box. So I know that I can make a really clear comparison. I've looked at what it would be as a fraction. I've written it 7 out of 10, and I've written that comparison 70 out of 100. So I can clearly see that I I have got 7 tenths, yeah, 15 over 25 and 13 over 20. I'm showing different ways that I can see it. Okay, so can you find different ways to prove it yourself? You might have a really, really nice way of proving that one for me. Okay, right. One quick thing to think about before we move on to our guided practice. So this is Charles's method. So Charles has said that 7 tenths is equal to 0.7. He said that 15 25ths, 15 over 25, he's found that equivalent 60 over 100, which he knows that he convert to 0.6. And then he's done the same for Elliot. And he has said, therefore, that Ruby's method is the best score. Or sorry, Ruby's is the best score. Do you think that his method is the most effective way of finding it? And why? You might decide you think his is, you might decide it's not. So if you can explain to me why. Okay, I'm not going to tell you what I think. It's up to you what you think. Okay, guided practice then. Pages 61 to 62, so you've got 2 pages for your guided practice, so don't just skip on after the first page. So we've got, can't remember her name, took a test. Out of 10 arithmetic questions, she got 8 correct. So how would we show this? So think about what we've just done and use that knowledge to answer these questions. So you convert it into out of 100, and that'll give you a percentage. Okay, it's much, much easier. All right. So out of 5 problems, that means our denominator is going to be 5. Then we've got another question here. Write each of the following as a percentage. So each time you need to think about making it out of 100 to help you. Your workbook is 3 pages today, so you may not get onto your extension. Those of you who usually do may not get onto your extension today. Don't panic if you don't. It really doesn't matter. It is an extension for a reason. See how far you can get through this. So some more questions where we're thinking about converting from a different denominator to making it out of 100, and that will help us to show the percentage. Okay, we've got that there. And then this one's a nice question here. All right, think really, really carefully about how you might do that one. And then your extension then is some more questions, but this time we're thinking also about decimals. So yesterday you were thinking about fractions and percentages and comparing them. Today we're thinking about decimals and percentages, so showing that link between all three of them. Great if you manage to get that done, don't panic if you don't. And then maths teasers, again, you have got some questions from your maths teasers book. So questions 4, 5 and 6. I've put an extra one in there, so let's change that to 6. Again, really don't panic if you don't manage to get all of them done, because that's quite a lot to do. It's just there for you in case you need something extra. Okay, so I look forward to seeing your work today, and I hope you get on really well with that strategy of using show it, draw it, explain it, prove it for me. I'm looking forward to seeing how you do.